Electric potential energy, or electrostatic potential energy, is a potential energy that results from conservative Coulomb forces and is associated with the configuration of a particular set of point charges. Within a defined system, an object may have electric potential energy by virtue of two key elements: its own electric charge and its relative position to other electrically charged objects. The term electric potential energy is used to describe the potential energy in systems with time-variant electric fields, while the term electrostatic potential energy is used to describe the potential energy in systems with time-invariant electric fields. Definition: we define the electric potential energy of a system of point charges as the work required assembling this system of charges by bringing them close together, as in the system from an infinite distance. The electrostatic potential energy, UE, of one point charge Q at position R in the presence of an electric field E is defined as the negative of the work W done by the electrostatic force to bring it from the reference position RREF to that position R, where E is the electrostatic field and ds is the displacement vector in a curve from the reference position RREF to the final position R. The electrostatic potential energy can also be defined from the electric potential as follows: the electrostatic potential energy, UE, of one point charge Q at position R in the presence of an electric potential is defined as the product of the charge and the electric potential, whereas the electric potential generated by the charges, which is a function of position R, units. The SI unit of electric potential energy is the joule. In the CGS system, the erg is the unit of energy, being equal to 10⁻⁷ J. Also electron volts may be used. 1 electron volt equals 1.602 times 10⁻⁹ J. Electrostatic potential energy of one point charge. 1 point charge Q in the presence of 1 point charge Q. The electrostatic potential energy, UE, of 1 point charge Q at position R in the presence of a point charge Q, taking an infinite separation between the charges as the reference position, is, whereas Coulomb's constant, R, is the distance between the point charges Q and Q are the signed values of the charges. The following outline of proof states the derivation from the definition of electric potential energy and Coulomb's law to this formula. 1 point charge Q in the presence of n point charges Chi. The electrostatic potential energy, UE, of 1 point charge Q in the presence of n point charges Chi, taking an infinite separation between the charges as the reference position, is, whereas Coulomb's constant, Re, is the distance between the point charges Q and Chi are the signed values of the charges. Electrostatic potential energy stored in a system of point charges. The electrostatic potential energy UE stored in a system of n charges Q1, Q2, Qn at positions R1, R2, Rn respectively, is, where, for each I value, phi is the electrostatic potential due to all point charges except the one at Re, and is equal to, where Rij is the distance between Qj and Re. Energy stored in a system of 1 point charge. The electrostatic potential energy of a system containing only 1 point charge is 0, as there are no other sources of electrostatic potential against which an external agent must do work in moving the point charge from infinity to its final location. Energy stored in a system of 2 point charges. Consider bringing a point charge, Q, into its final position in the vicinity of a point charge, Q1. The electrostatic potential phi due to Q1 is hence we obtain the electric potential energy of Q in the potential of Q1 as where R1 is the separation between the 2 point charges. Energy stored in a system of three-point charges. The electrostatic potential energy of a system of three charges should not be confused with the electrostatic potential energy of Q1 due to two charges Q2 and Q3, because the latter doesn't include the electrostatic potential energy of the system of the two charges Q2 and Q3. The electrostatic potential energy stored in the system of three charges is energy stored in an electrostatic field distribution. The energy density, or energy per unit volume, of the electrostatic field of a continuous charge distribution is energy in electronic elements. Some elements in a circuit can convert energy from one form to another. For example, a resistor converts electrical energy to heat. This is known as the Joule effect. A capacitor stores it in its electric field. The total electric potential energy stored in a capacitor is given by where C is the capacitance, V is the electric potential difference, and Q the charge stored in the capacitor.